Very good. Just fun. One, fire.
Are you like me? Do you like watching fruit explode and also enjoy physics? Well, if so, there's probably only one place in the world where those two great tastes come together. Pumpkin Chunkin, America's annual contest to see whose homemade machine can hurl a pumpkin the farthest. Every November, thousands of amateur engineers, equal parts Da Vinci and Gallagher, converge on a farm in Delaware to put their contraptions to the test. They compete in divisions based on what kind of machine they've built, and whoever's device hurls their squash the farthest wins. Machines at the Pumpkin Chunkin Festival rely on the release of stored energy to get the pumpkin airborne. This energy comes from some external force that's exerted on a part of the machine where it's been pent up as potential energy. For example, there are the air cannons, which release all at once the potential energy of gas that's slowly been pressurized inside a container. And then there's what the contest calls centrifugal machines, where a motor spins the pumpkin around a tether, which is pretty cool, even though centrifugal force is not a thing. But from where I stand, the most delightful Pumpkin Chunkin physics are found in the class of machines that you probably know as catapults. Yes, they're not just for smashing castles or upholting cats. There are actually many different kinds of catapults, including the MANGONELs, TREBUCHETS, and TORSION machines, each using a slightly different sort of force to create the potential energy. When you're thinking of a catapult, what you're probably seeing in your head is a mangonel. Its main feature is a long beam with a bucket on one end and the other fastened to an axle. The bucket end of the beam is usually attached to a sling by the machine's main frame. Then it's pulled down to apply the force of tension. This tension is what stores up the machine's potential energy until it's released. For Pumpkin Chunkers, though, catapults can use springs, cords, rubber, or dead weights to apply tension, but they've added an extra touch of genius to the traditional mangonel. Instead of just a bucket on the end, what it has is a sling. What's the genius in that? Well, it gives the machine a second fulcrum, or pivot point. The first fulcrum being where the beam meets the axle, but when that's released, it throws up the sling, which amplifies the power of the first fulcrum. This is all very similar to how trebuchets work, but they're a little more sophisticated, as far as catapults go. Rather than holding all the potential energy at the tip of the beam, where the pumpkin is, trebuchets rely on a counterweight at the other end. Again, the beam is pulled down to set the device, but instead of tension being the force at work, here, it's simply gravity. The heavier your counterweight is and the higher you lift it, the more force you get out when it falls. As a result, trebuchets are much more efficient, they tend to shoot a lot farther, and are more accurate, giving you more chunk for your buck. Finally, you have what the hardcore chunkers call torsion machines. Most of these kinds of catapults are hybrids of the first two. They have a sling at the pumpkin end, just like a trebuchet, but instead of gravity, they use the force of tension, like a mangonel. Unlike with a mangonel, though, the tension is applied to this machine by twisting a length of rope around the bottom of the beam. It's the same idea as twisting the rubber band on a propeller toy airplane. The twisting, or torsion, is just tension applied in a rotating direction instead of straight up and down. And we all know what happens from there. But please don't try this at home unless you have a scale model or something.
Are you ready to create your catapult? In your bag, you're going to have either a pumpkin or an apple or maybe even a piece of candy that you can catapult. Here are some directions on how to create and make your catapult. You need your craft sticks, rubber bands. You don't need tape. I already hot glued a lid for you. Careful with the rubber bands. Sometimes you might pop yourself. If you need some help on creating the X, ask a grown-up. Remember, I already hot glued a cap, so the cap should be on the top layer of your catapult. This is your bucket to launch your object. After you create your catapult, make it a challenge. See if you can create some targets.